Hello everyone, I'm Ozgur, the General Manager for Automotive and Manufacturing at AWS, and I would like to welcome all of you to today's AWS Automotive and Manufacturing Customer Meetup. We'll kick off with a panel discussion today, and I'm extremely privileged to be discussing the latest and greatest when it comes to software-defined vehicles today with two outstanding guests who have not only been talking about it, but also be doing it every day, which is very different. I think we have a lot of people talking about SDV, but these two gentlemen have been working on this for a while, and I would like to introduce them to get going. Andrew Polyak is the Chief Technical Officer, CTO for Panasonic Automotive Systems Company of America. As CTO, Andrew leads innovation initiatives, including advanced engineering, advanced UX, UI, ID, and product management. Andrew has more than 25 years of experience and has been a part of successful technology launches in over 200 million vehicles, smart cities, IoT devices, and industry initiatives. Welcome, Andrew.
Hi, thank you for having me.
And my second guest is Hemant Sikaria, who is the CEO and co-founder of Sibros, a leader in automotive and software, providing a complete end-to-end solution of over-the-air software updates, data logging, fleet management, advanced data analytics to over 30 plus OEMs globally. Before Sibros, Hemant spent 5.5 years at Tesla, where he helped develop the Aura software update system that was able to update all ECUs across multiple vehicle model lines, such as Model S, X, and 3. Welcome, Hemant.
Thank you so much, Ozgur.
So before I turn over to our panelists, maybe just to kick off the discussion here, I'll just introduce the topic here a little bit. I mean, as you know, software-defined vehicle is any vehicle that manages its operations, adds features, has the ability to upgrade its functions primarily through software and over-the-air updates. Traditional automotive manufacturing used to follow a rigid development model. Vehicles were designed with fixed hardware and dedicated electronic control units, ECUs, as we call them, requiring 3 to 5 years at best. And this is probably improved timeline from conception to market launch. However, the changes in smartphone technology, the expectations in consumer preferences have fundamentally transformed these expectations, making conventional vehicles appear quite obsolete much faster than by comparison. Your vehicle that you bought 3, 4, 5 years ago is already becoming obsolete. So how do we address that? I think this is a major challenge across the industry. The market reality has driven the industry towards SDV, software-defined vehicles, representing new approaches where critical vehicle functions are software-controlled and can be enhanced through post-purchase updates. What are some of these things this is impacting? It obviously impacts how we architect hardware, how we architect our software infrastructure, development methodologies, data management systems. So in this panel, what I'm going to do is discuss with our two distinguished partners, Panasonic Automotive and Sibros, on the topic of accelerating SDV value realization. Because there's also a lot of discussion in the industry. Okay, we all understand what SDV is, but what's the value? What's the value and how can we accelerate to that value? As you can see, you're reading all on the news, our OEMs are under a lot of pressure. So how can we accelerate the value that they could deliver to their customers? I also would like to highlight that Panasonic Automotive and Sibros are collaborating in our Santa Clara prototyping and innovation lab, building a demo together. And if you're interested after this event, please reach out to your AWS account teams, your contacts, to schedule a visit to our Santa Clara lab to see a live demo. We would be more than happy to host you there. If I can get started, maybe I'll turn to Andrew for my first question to kick off this discussion. Andrew, what are the changes you're seeing in the SDV landscape and also across the supply chain?
Sure. Yeah. Geez, I don't think we have a few hours, so how to summarize? I think I would start with one key point before I go through the rest of it, and that's that truly the business model for a lot of the SDVs is still hasn't fully materialized for all the OEMs. And that's because there are quite a few complexities that are all at war with each other at the moment. I think one of the key ones that it's materializing and you're seeing live in real time is that in order to enable a SDV that would live the 11 years that you have that vehicle in place, you really have to future-proof the hardware, meaning you don't thrift the hardware knowing that it's going to change quite a bit over the life cycle of the vehicle. The software will change quite a bit over the life cycle of the vehicle. And you're seeing this affordability gap with many of the car OEMs that are partially a challenge of trying to give enough compute power in the vehicle to last that 11 years. So that affordability gap is playing out right now, that you see many OEMs re-looking at their architectures, re-looking at their strategy. So that's a big recent change that's happened. And honestly, you can look at things like cloud computing and offloading of some of that compute power as a strategy to start thrifting that in-vehicle platform a little bit, but it doesn't solve all of the issues. But I'd say one of the big things is this affordability gap mixed with how to monetize that increased power and that increased solution. And another big challenge that we're seeing in the SDV landscape is this complexity that's exploding within the vehicle environment. So there's new operating systems, there's new third parties that are bringing new experiences to the car. You mentioned the consumer life cycle, but try running an app on your 10-year-old mobile device, and many times new operating systems aren't available, new applications aren't available, but you're already starting at a little bit of a deficit because the silicon going into cars typically are a few years old because they have to have automotive grade versions that can withstand the heat, temperature, all the other things that will go on. So the new technologies coming from consumer is disrupting the automotive life cycles as well, because the speed at which you're developing new solutions is coming out. And that's creating this big need of a separation of PPAP, validation, everything between hardware and software. And there's this need for abstraction between the two. And that's where a lot of the development that we've been doing, you have all this complexity, huge amount of code, huge amount of third parties, that you need massive parallel development, massive parallel integration and testing. And that's where we get into this need to start developing, isolating hardware from software. So we do a lot with a technology called VirtIO, and that's a way to kind of separate some of those elements, the hardware from the software, and then allows you to run a lot of that code that will run binary identically between a cloud environment like on AWS and an embedded target like our automotive hardware that we use. I think that's a big part. And then the last piece I would say is the last kind of trend we see going on is there was this pull by all the OEMs to really bring most of the software, especially most of the development, but quite a bit of the software in-house. And there's a reason why that makes sense, is that when you get to this level of complexity and the amount of code and the amount of integration, you can't award business to a single supplier over the entire breadth of vehicles you have, especially with all these huge conglomerates of new vehicle companies that are spawning from the acquisition of other companies, right? So you usually award that to multiple suppliers, and you can't afford to really build a complete solution with that complexity across two suppliers that could range in the hundreds of millions of dollars per, right? So it makes sense to try to say, okay, we want to leverage this technology, but bringing it all in-house also has you do a lot of non-differentiating features, whether that's power management, fast boot, the platform enablement itself. So really we see this pendulum swinging back and forth in the case of SDVs, and I think it will come to what we often refer to as more of a build to platform. So you could, and it's a logical separation point again with VirtIO, you can develop all the same solutions in the cloud of your user experience, a lot of your applications, a lot of your integration points, but then have the other heavy lifting of the platform enablement that's not really differentiating power management, power moding, fast boot, all that done on the embedded target, and that can be awarded to traditional suppliers. So I think as that gets fixed, you'll see this kind of fast adoption of SDV, and it'll make it easier to launch new features, separate the consumer life cycles, and deploy it in the cars.
I love what you said about differentiated, undifferentiated heavy lifting. It's a topic that we also discuss with our customers. one of the things that I see in the last years is because there has been a lot of focus on OEMs becoming software developed, like building their own software development capabilities. Just because you can actually build it doesn't mean you should build it. I think finding that demarcation of value creation is extremely important. So I think those architectural decisions are crucial. Great points. Thank you for that, Andrew.
And you don't even think about there's a lot of business aspects of liability, warranty, and indemnity that OEMs really haven't been really positioned to own that. And they've used suppliers as, companies that have to look at a lot of those technologies or those legal concerns. So we didn't even touch on those. But yeah, there can be we could spend a long time on just the changes that are happening in the industry around that.
Absolutely. Come on, let me turn over to you so you don't get bored. I have a question for you. I think we've been talking about software-defined vehicles now across the industry. The definition, I think everybody has a little bit of a different definition, but I think what's probably common, everybody believes that it could be, the adoption could be faster. So what do you think can be done to accelerate adoption and faster spread of use of SDV?
No, thanks. Great question. I think kind of building on what Andrew already mentioned, a couple of things that are happening and things that can accelerate this include the ability to have open APIs that are kind of industry-wide standard. And these APIs could be for communication between controllers within the vehicle, as well as for the vehicle to communicate with an off-board tool, like a diagnostic tool. And similarly, having open APIs and standards for communicating between the vehicle and the cloud. And then from the cloud, how do you communicate from one backend, which is the OEM's backend, to kind of share information with other third parties through a standardized interface. So one of the good things that has happened is there's a standard, a recent ISO standard called SOVD, which is Service-Oriented Vehicle Diagnostics. And it's really starting to pick up steam. We're seeing many of our customers adopt this. And what it essentially does is help have all diagnostics and software updates be to a standard API interface on the vehicle side, so that you can do offline updates using a diagnostic tool, but you can also use the same interface and APIs to do updates or diagnostics from the cloud. And this really helps create more standardization. So that's one of the things that's already happening. I think there needs to be more initiatives around having these kind of open standards across the different segments of the end-to-end software value chain. The other thing that I think that is hard, and we've seen this kind of when we talk about differentiated versus undifferentiated lifting, that 15 years ago, every OEM had their own data centers and they wanted to have everything custom. And then over time, cloud has taken over, right? In the sense that there's no need to build your own data centers when Amazon could build those and provide something that's a lot more standard, a lot more efficient, a lot more performant. And the resources that anyone on the cloud can provide are much bigger than what any OEM could build on their own. And that kind of same thing needs to be applied to a lot of the base software that goes into vehicles as well. That's not differentiated, right, in that sense. So it doesn't mean that there's no innovation happening in that base software. It just means that that innovation should be, the onus should be on sort of the entire community, right? So having an open source based software layer that can be used across different types of hardware, different chips, different operating systems would help significantly to create more standardization and have more of the discussion be about the value-added applications that are built within the vehicle and on the cloud that use this sort of base software. So I think those are some of the things that I think could really help with democratization of SDV and accelerating the journey. Because today every OEM tries to do all of this on their own, or has some supplier that has some secret sauce that they're using, and it might seem like they're speeding up, but it's actually, it would be much faster if everybody had a common layer like Linux, right? For example, or you think about other open source collaboration systems and operating systems, right? So that's what I would say that could help.
Awesome. I think these are amazing architectural discussions in terms of accelerating the adoption, and it's very much in line with the types of conversations we're also having with our customers around standardization, open interfaces, open source. I have a question though. I mean, with all this, if we can extract ourselves from this technical discussion and focus a little bit on the end customer, ultimately SDV needs to deliver some value for the end customer. So my question is to Andrew. Andrew, I mean, what does SDV mean for the end customer? What would it mean for my parents? What would it mean for just an individual who was driving the car, who is owning a car, who is making a decision to buy a car? What do you think?
This is what I'm most excited about, and I think the fun part of SDV. I can't answer for your parents because I don't know what they like, but I can tell you, the way I paid my way through college was working in car audio and also working at a company called Carver Corporation, which was a high-end audio company out of Washington State. And being kind of one of those audio heads for so long, seeing the announcement from Apple recently about enabling spatial audio over CarPlay was really exciting for me, because we've been demonstrating Dolby Atmos and other spatial audio technologies in demo vehicles for a while, but there is a little bit of a challenge of paying for the bandwidth if you're building it in a TCU and streaming it over something like Tidal, and there were very few apps that supported spatial audio in automotive. Tidal was really the only one. So now watching it have a pipe through your phone and getting Atmos and other spatial audio technologies into the car, man, just listen to it. I mean, if you look at some of the cars that enabled the first SDV experience for spatial audio, like Rivian, and you sit in the car and listen to the difference between a standard stereo audio and something like an Atmos environment, streaming audio into your car, and having a surround experience that exceeds, honestly, anything I've heard in a home theater system in quite some time, or at least as good as some of the top home theater systems. And that makes me excited to go in a car and have a car that has it, where I've never been really a fan of necessarily spending all the extra money on a premium brand that maybe sounds as good or a little bit better than some of the other in-vehicle electronics, but you get things like that. Other SDV experience you could imagine is being really personalized, not just as we think about setting the seats and setting the temperature and other things, but knowing adjusting ride performance based on the location, knowing automatically you're going onto the freeway and maybe lowering the ride height and going at a smoother ride, or you're going off-road because it knows you're going off-road, and being able to adjust the ride for an off-road experience. Other environmental or comfort settings, whether it's mood lighting or matching themes across an HMI you pick, or even downloading. I mentioned CarPlay. CarPlay has a kind of decouples a little bit that hardware experience that I mentioned, where you have an upgradable device you're bringing into your car on a regular basis. But that's really been kind of limited just to a similar experience across all brands. But they've announced something called Ferrite that will allow it to actually show an experience across your instrument cluster as well as your IVI and potentially other displays. And they have thought through how you do the functional safety to allow that experience to actually be projected still from your device. So all these things could suddenly not have to be like, darn, I bought last year's model and now I have to wait till I decide I'm going to upgrade my vehicle to get something that I just heard that comes out. but instead know that that could be an upgrade of an experience that I'm really excited to experience. I don't have a car today that I wish I could upgrade my audio system and have spatial audio, but I think it won't be very long until we have that kind of environment across all these SDVs. So I'm really excited for it. I don't know, what would your parents want?
They love listening to music, so I think this will resonate with them.
All
Absolutely.
right, great.
That's awesome. Look, I think we're kind of getting to a conclusion here. I have a final question for both of you. I mean, you're coming into this field from different angles, but I think working towards a similar or same objective, both in terms of the end outcome as well as how to get there, with some complementary capabilities and skill sets. The question to you is, how can Panasonic and Sibros collaborate to help customers accelerate their SDV journeys? Like how can you work together? What are some of the things you're doing or you are working on or you're planning that could help with this? Maybe Hemant, let me start with you.
I think as you mentioned at the very beginning, Panasonic Automotive and Sibros were already collaborating in the Santa Clara prototyping and innovation lab that AWS has, and we're building together on a demo there that is production grade and can be deployed to customers. And the idea there is to use the vSkipGen's advanced capabilities in SDV that Panasonic provides, along with comprehensive over-the-air updates and data logging and telemetry, and have that all come together in sort of a one-click deployable solution through AWS Marketplace, right? And I think that is something that I'm very excited about, and I think that can really help accelerate the journey for a lot of the OEMs.
Maybe I'll add on to it since you mentioned vSkipGen, just for the audience. We have a product that we call SkipGen that is really a reference design in automotive. That's a hardware platform. We've gone through a few iterations, but the current one is on the Qualcomm 8295 base silicon is the hardware. And then we also have, I don't like using digital twin because it means too much to too many people. So I'll say an environment that it has bit parity on AWS that we call vSkipGen, that the code that runs there without recompilation, without anything, can deploy and run natively on the physical hardware as well. Even though on a G5G you're running an NVIDIA processor, and our embedded target you're running a Qualcomm, it just demonstrates the power of things like VirtIO and others to run in different environments, but without any change to the code. That bit parity that will drop right in and run. And we've expanded it to also integrate to other virtual ECUs. We've done some with Electrobit and others that have done ECUs that tie into this virtual environment in the cloud. And we also run a variety of different operating systems like Android 15 and auto-grade Linux and others that run in this virtual environment that then could deploy to the physical environment. But one of the key points that, and by the way, it has all your virtualized CAN, virtualized GNSS, all the things, even Bluetooth, and the ability to connect in Alexa and run that in the cloud on our virtual environment and drop right on the physical target, all that nice stuff. But where it fits into something like we could do with Sibros is you still want to show that you can upgrade that virtual environment as well as the remote ECUs in that virtual environment and show how you do it in the physical environment, right? So you might upgrade the operating system from Android 14 to 15. You might go in, we look at things like FOTA, so firmware over the air update, which would be on the physical target. Software over the air update, which would be all those things above VirtIO that we would work on, and ECU reflash that could go across that virtual network and reflash those other modules across, that we could really work with a company to enable that, and it would run just like you'd run it in the car. And so that's where I think this collaboration could be interesting, is allowing you to really show a decoupling of those life cycles And by the way, the bit parity doesn't have to go to our hardware, even though we call it SkipGen and vSkipGen. We have companies that are developing it and running on their own targets. That has nothing to do with Panasonic on the physical hardware. So it's not dependent on us from a tier one of the physical hardware, but allows you to do that development and then run it right down into the hardware you choose, as long as you're using VirtIO on your physical hardware. Yeah.
Awesome. So thank you very much for that. Let's see, maybe we open up for questions if there are any questions from the audience.
The question, you can actually raise a hand, use the WebEx raise hand feature, and we will unmute you. Please go ahead and do that.
If there are no questions, I definitely have another question.
Yeah, no questions as of now. Yeah, I think I see somebody raised a hand. Sai, I'm unmuting you.
Fireside chat. Really appreciate the technologies that people are getting into. I joined in the middle, so I'm not sure if this was shared. So what are the cybersecurity threats that you foresee in terms of SDV and the new technologies for OTA?
Do you want to answer on the photo side?
Yeah, sure.
Yes. Go ahead, guys.
I think cybersecurity is one of the biggest things that kind of goes hand in hand with software-defined vehicles, because if you have more software in the vehicles, you potentially have more vulnerabilities. And if the software can be affected remotely through software updates, then you have the potential for doing more cyber crime, let's say, or hacks and other things. And so there are a lot of different companies that focus just on cybersecurity for vehicles. There are some open standards and ISO standards for this as well. On the Sibros side, for example, we use a standard called Optane, which is meant for having safe and secure software updates through from the cloud down to the vehicle, down to the individual ECUs. But it is an open concern. It is something that will need constant innovation, constant efforts, and it will continue to evolve. I think the overall security landscape has evolved tremendously in the last 5 years because of more and more software going into vehicles. And there's also an element of the vehicle making itself be secure in a way that if one vehicle is compromised, that it doesn't compromise an entire fleet of vehicles. So there should be no way for someone who has physical access to one vehicle to then also get the ability to hack into a fleet. And so you can use asymmetric keys to help ensure that you can have certificate management and certificate rotation for each of the vehicles to help mitigate that. And then there are a bunch of other things such as timing and getting a signature on a new software update, so that, for example, you have a vehicle which is running version 3 of software and version 2 had some security issues. A hacker would like to downgrade the software from version 3 to version 2, and there needs to be checks to prevent that. And that can be done by having the vehicle check with the cloud, hey, what software am I allowed to upgrade to or downgrade to, and use that to ensure security on the update. But there's again, like any other topic, this could be a fireside chat on its own. And but I hope I, at least high level, was able to answer that question. Thank you.
Maybe I'll make the short answer. I will say you can always tell on LinkedIn what the hot button is. For a long time, it was cybersecurity, where you get 500 cybersecurity requests from people on LinkedIn. Now it's AI, right? So absolutely, is it a concern? And when I talked about the roles changing, where the OEMs are taking on more responsibility, that's a really good example of where a tier one would typically be on the hook for liability, warranty, and indemnity, even around cybersecurity. And I think many of the OEMs haven't been thought through exactly the implications, or maybe know what those are as they do their own software, and they're responsible and on the hook on the cybersecurity. It was a shared responsibility because the OEM is ultimately responsible for their car. But now it's looking and saying, okay, the cost for this, if we have a hacking incident, there's no shared cost in many cases. So it'll be interesting as it continues. And I think that's a great example at a platform level. When I said build a platform, there's an expectation that that platform has a lot of security principles in the vehicle interface and other things that could remain. And you really, OEMs could focus more on the differentiations, not on the, how do I make this thing safe?
Amazing. Andrew, Hemant, big thanks from our side for participating in this discussion. A lot of great insights. Like I said when I kicked off this, I think it's so much more credible to hear it from people who are actually doing this every day, hands-on. So really appreciate your insights here, and your collaboration as well as partners. Looking forward to working with you guys.
Yeah, thanks for having us.
Same here, Ozgur. Thank you for having us.
Thank you.